Okay, while we're all searching for sources for good token SITs, I thought it might be fun to build a virtual lamp in LTspice. I don't use LTspice a lot. I learned to use Spice with a different simulator, and LTspice works a lot differently. But I know that LTspice is the popular one with DIYers, and so if you'll bear with me, we'll give it a go here. The first thing we want to do is place a component that will stand in for our static induction transistor. So I'm going to select the NJF, N-channel JFET here, and place that. And when you're done placing a part, hit escape. And then we'll need some resistors. We'll need a resistor to represent the light bulbs or the drain load, and a resistor here at the input, and a resistor to represent the speaker. And we'll need a ground. And we'll need some voltage sources. We'll need an input signal. And a B plus voltage. And we'll need a bias voltage. I need to flip this bias voltage, and if I just hit Control R, I can rotate it. Okay, and now I think we can start wiring things together. Select the wiring tool and just move those crosshairs. There we go. And when I'm done with a wire, I just hit escape. Move that ground. Oh, I see I forgot our capacitors. Oops. Alright, let's... And hit Control R to rotate. Oh. Okay. Oh, Okay, it did let me just drop that on there. Nice. Okay. All right. How does that look? Are we on the right track here? I think so. So now we've got the basic schematic, and we need to start assigning values to some of these parts. So let's go over here. You can right click. There we go. And you can see the pointer there. This is going to be 84 volts. And this is going to be 8 ohms. $23 ohms on the light bulbs. I'll make this capacitor 10,000 microfarads. Make this 10K. Micro. And I went to the advanced tab here. I'm gonna enter 1 volt in the AC amplitude text box there. All right. Have I missed anything? Okay, for the bias voltage, let's make that about 6. That'll be minus 6 volts. Okay, I think that's everything. Now, we need to implement our static induction transistor model for this NJFET symbol here. So the way we do that, okay, we're gonna control right click on the NJF symbol there, and the prefix we're gonna change that to X. No? There we go. And whoops, I need to control right click. I need to change this value to 2SK180. That's what we're going to use in we're going to reference that in our model. Okay, and we're almost there. Now we're going to go and add a spice directive here, and it's a .lib, and we're going to tell it where the model is. http:// www.spice audiohobby.com/spice/2sk180.txt, and it will then download this. When I run the simulation, it'll download this model. Trying to place this out of the way. Okay. All right, so I think let's see. I think we're all wired up and ready to test this out. The thing that we want to do here is run an operating point analysis and see if we've got all our DC parameters set up correctly. So we click on this little running man here, and over here is DC operating point, and we'll just say OK. And you can see these are some of our operating point values. This is our B+ node. This is the voltage at the drain. And that should be around 36 volts. And this is the current through R1, 2.18. So I need to adjust the bias a little bit here. So let's make that, let's try about 6.2. And we'll run that again. And you can see, okay, we're getting closer now. 2.12, 35, 84. This is pretty close. We can try 6.3. About 36, 84, 2.09. That's pretty close to the real thing now. So that's the operating point analysis. Okay, so the next thing we probably want to figure out is how much gain this thing has. So we'll do an AC analysis, and I can do let's do a decade sweep, and we'll do 120 points per decade, and we'll start it. Well, let's start at 10 hertz and go to I don't know, 500 kilohertz. That will run, and then we have to probe the circuit here. So I'm going to probe it at the speaker, at the output. And this dotted line here is the phase, and the solid line is the magnitude. And you can see we got about 13 dB of gain. So that's that agrees with the real thing as well. Now you might be looking at this and saying, yeah, but it's not even down at 500 kilohertz. Your model is no good. But if we want to check that, we need to make a little change in the circuit here. All right, so let's change the output impedance of our source here. And we'll run the AC simulation again. And you can see, let's see, we're at 13. And so we're down to 10. Trying to find it there. 10. At about what, 18 kilohertz or something like that. So that is the effect of the input capacitance that's built into this model. There's a couple thousand picofarads of input capacitance. Now, to demonstrate the value of having a really low source impedance when you have high input capacitance like this, let's go and let's change this output impedance to 50 ohms and run it again. And you can see that the frequency response is a lot better now. Okay, and then one other thing that you'll probably want to do is look at distortion, and you can do that in LTspice using the Fourier directive, and we set that up like this. We're going to add a directive which is .4, the frequency 1 kilohertz, and we need the output node, the voltage at, and the output node at our speaker is N003. And I'll just place that, and then you can see also I've given this an amplitude of 1 and a frequency of 1000 hertz. And then the last thing we'll do is we're going to change this to a transient analysis, and I'm giving it a stop time of twice the period. It needs to be a low multiple of the period, it seems, in order to give good results. And then we just probe it like normal. Here's our transient analysis, and then if we go to the error log, view error log, you can see that the total harmonic distortion at this particular level is 0.89%. And then of course you can go and play with all these values, the power supply, the resistance, the output load, the bias value. You can mess with all those and see how it changes the distortion and output. So there you go. That's a really quick tutorial on how to build a lamp in LTspice. So thanks for watching.